From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Yeah, first of all, I'm really surprised to see so many people of you, because I was thinking, hey, I'm talking about an OS. Yeah, and in Kubernetes area, in containers, we try to get rid of the dependency of operating systems. Yeah? And second time, I'm talking about the dilemma, yeah, which is maybe a little bit negative. So I'm really happy that you all are here. And yeah, when I was thinking about this title, I think, okay, how should I start this document or this talk? And for me, this dilemma starts with the idea of DevOps. And here it comes into my mind the story about pets and kettles. And in this area, this is my way where we have different approaches, different ways how we think about operating systems. Because in the traditional way, yeah, we had also these pets. Just as a question, you all are aware of this story about pets and kettles? Perfect, okay. So here we have a traditional operating system, and it is well managed. We love it. Yeah, we patch it, we customize it, we configure it. On the other hand, the DevOps engineer, and you see he is completely relaxed in this picture, to say, I have everything automated. I don't care about it. Yeah, I have just my microservices. I put everything together and hey, what's this? An operating system. I don't care. And so in this case, this was the starting point. And if we are looking at the areas and the ways how operation is done in these both areas, it's somehow similar, on the other way, a little bit different. So the traditional ops has for sure something like monitoring, logging, security, all these systems, and they have a change system management. So if anything on these systems must be changed, there is a well-established process to do this. We have, on the one hand, updates repositories, so software updates, and these will done via change management with a lot of magic going to my systems. The DevOps engineer just says, hey, yeah, sure, I have also my security tools, my logging tools, my monitoring. We have learned, I believe, all this is a little bit different to what we have in a traditional way, because we are agile, we are dynamic, not so static, old school like the traditional ones. And our main part is a CI/CD. Everything is automated. We take some new code from the Git. We add repositories. We are using existing images, container images from our registry. We are creating users. And at the end, we are putting this as microservices on our Kubernetes cluster. And we are doing this in a completely different speed than the traditional ones. On the traditional side, we have releases, maybe quarterly base or half a year, depending on which kind of operating and application you have. On the DevOps side, we are talking about weeks, days, or hours where we new releases put on. And we have different areas where we have a Linux operating system. So on the one hand, we have still in hardware or in virtual machine, which is used as the host OS. So Kubernetes is just an application. And this is one of the approaches which we can take if we think about how to manage this Linux OS to say this is more or less a traditional application. Yeah? So give this host OS just in the hand of the traditional ops and say, please manage this. Use your lifecycle to manage it. On the other hand, we have the Linux OS inside of a container. And this is for sure never be in the hand of the traditional ops. This is something you as a DevOps or as an engineer have to take care about it. On the other hand, it's a Linux OS. And in most cases, at least which I am aware of our enterprise customers, there are rules for Linux operating systems. Yeah, so how much time do you have to fix a CVE? How much time do you have to update this? And you will say, hey, sorry, a container OS, I will never update. How should I do it? I have not an SSH connection to it. I cannot run apt update or whatever command. So this needs to be done on a different way. On the other hand, this Linux OS itself, which is running the Kubernetes host, you can also treat this as a cloud-native part. So why not using the same concepts of the DevOps for the host OS would be the second option. And this I would like to deep a little bit more in and show it to you. If we are talking about the containers itself, we have not really an option. And you need an image as a base, for sure. You can start with a Scratch container image, just add your application, but in most cases, you will have some kind of operating system inside. And here you have only one choice to say, will I use something existing? I'm going to a distro like Alpine, RHEL, SUSE. We have BCI-based container images and use it. Disadvantage here is you have no control about it. When the distro delivers a new one, you can use it or not. But normally you can't ask them, hey, we have here a serious CVE. Have you already updated? You have to use it. So, and you have to trust them. You don't really know what's in for sure. Okay, you can have a look at it, you can scan it, but at the end you need to trust what's in. The other way is, okay, I create my custom container images. There we have several tools like EasyS1, Docker Build, Builder. We as SUSE have Kiwi. I'm not sure if someone knows Kiwi? At least one. Okay, 2. 3, perfect. So you can use this to create your own images. Someone told me when I started with all this Linux journey, never trust an RPM which you have not built yourself. And I have said, okay, more or less this also applies to containers. You can only trust them when you have created them. But then it's your responsibility. It's an additional effort you have to take for this. And you can only use this with custom containers. So if you create your own customers, if you are in a situation where it's a third-party software which delivers the software just as a container, you can't change the operating system there. You have to use it what it is in. And why should this matter? So because the OS itself, this is the first entry point for any security issue. So if a CVE exists, and it's something which you can also try on your own, scan a current Postgres container from Docker Hub. Most of the CVEs are not based on the Postgres. This is on a current state. Most of them are on the operating system inside. And then you have to discuss, okay, can these security problems be attacked because it's running a container? Maybe it's secured, but this doesn't care about your policy security officer. He says, sorry, you are using an operating system which has a CVE, fix it. And he says, I don't care that I can't be attacked. We have a company policy to say, fix your CVEs. And this could be a problem. But at the end, only these two parts. Now let's switch to the host OS. So, and there we have two options. And also mentioned, we can use images in the same way as on the container side to create our host systems. In the easiest way, if you are running virtual machines, it's common state that I do not start with insert my CD virtual and run through the installation process of the host OS. You are just using images. And this is the cloud-native approach. So it means if you have a new version of your image, you throw it away, you start with a new image, redeploy your server, join it to the cluster, and be happy. Ideal it would be if this update process is controlled by Kubernetes, because we are running and talking about a cluster, so you can't delete one node just if you want. There are some container on it, for sure. Kubernetes will restart them, but depending on your application, you will have at least a short outage. So it would be cool if your Kubernetes cluster is aware of, hey, this node will disappear in some minutes. Please drain it so that it is in maintenance mode and you can do it. But this means also if you are using images, any change and any update means you need to reboot your systems, which also has a longer downtime than just do an update or an online update. And if to do this, you need a patching system. And this is completely, that's what we have done since decades in the traditional operating system. Then there we are not replacing, we are using our pets, so we are taking care, we are patching them, we are helping them, we are configuring this. So in this way, we can use the traditional ops. On the other hand, yeah, for sure, a Kubernetes cluster, this is just one application on one server. So it's easy to standardize. So we can automate this quite easy. But on the other hand, still the same problem as here. We have to think about it's a cluster. So if we patch and update and need to restart services or the whole server, we need to find a way how to inform our cluster about it. So let's see what we can do on the image side. Here I would like to highlight two ideas, two projects behind. On the one hand, Kubernetes itself has a solution called CAPI, Cluster API. This is a declarative API for Kubernetes for the cluster lifecycle manager. So you have a management cluster, and here you create resources like a cluster, a machine deployment, and you're using different providers, how this management cluster can control your infrastructure. So you have an infrastructure provider which is able to speak to VMware, to the cloud, to bare metal also, so with Metal Cube, for example. You can control your bare metal systems. Then you have a bootstrap provider which is able to speak to this initial system and start the Kubernetes installation. And you have a control plane provider which will control and manage the life cycle of your Kubernetes cluster. This is standardized, so you can use it and combine it as you want. This makes it possible that you have the full life cycle of your cluster completely under control of Kubernetes. It's just another Kubernetes resource. An update process would be in this way: you add a new node, could be a virtual machine or a physical one. You deploy it with the new version, new image. Drain the old one. And if it's drained and the new one has taken over, you just delete it and move on to the next one. In this way, you can automatically move from one node to the other, create a new one, delete the one, and you will not have any downtime for your application. CAPI is doing this very well. What's not looking for is, where do I get my image from? So how do I create my image? And here we have, again, tools like Kiwi, Packer, Ansible. And we have to think about, okay, these are tools to package, but where do they get these sources from? And here I can leverage, and this is my idea, the best way, the existing traditional ops, where we have all these repositories. Normally, you have a standardized operating system inside of your company. And with these tools, you can connect to them to say, okay, this release we take over, and then we have at least the same versions, and they are agreed with security to say, hey, we have our standard Ubuntu, RHEL, whatever server, maybe it's also SUSE, and use it for it. And with copy, you are fine. But this image, maybe you think there is something missing. How can I adapt this and change it? And here we have one tool, part of our SUSE Edge product. And this is called the Edge Image Builder. It's a tool set which takes an existing image. So we have here, for example, a SLE microsystem. We have an image definition file, which is telling what needs to be done with this image. So something about network configuration, disk configuration, which packages should be included in this image. You can completely define the Kubernetes part, which should be included into the image. And stupid configuration files. You put this all together and create a new image. And this could be used now from copy, for example. Copy will use it, will control your physical server, for example, via Redfish, boot this new image on, and create your Kubernetes cluster. Everything what's needed, all artifacts are part of already of this image. So special if we are talking about edge deployments, where you maybe have a different or lower bandwidth, then it's a big advantage to have already as everything in place. And you can update, upgrade this, just create a new image. Okay, another way, and this is completely different from copy, is software called Elemental. Also a project created by Rancher. And this enables a Rancher management server, which is normally managing your multi-cluster environment, adding here the host functionality. And the idea of Elemental is, okay, we are talking about images. And in containers, we already have an image registry, OCI compliant, for using inside of the containers. Why can we not use these images also for our host OS? Answer is quite easy. A container does not have a kernel and no boot environment. And this is what Elemental is doing with the toolkit. It creates an OCI-compliant container by adding kernel and bootstrap parts and storing this in the default registry. So beside your application containers, you have also your host containers in the same way. And with the operator and all the other nice tools with here, you are able to manage your host OS in the same way as your containers. So an upgrade will be done inside of controlled from Kubernetes, and it will replace just the image on your host OS and will reboot. Here it's shown how it's working. So we have the Elemental toolkit. This creates, let me see if this now is working. Great. So we have the Elemental toolkit. It's creating an Elemental OS image, and this is stored in my registry. Now we have a Rancher server. So here is running the Elemental operator. The operator will load this OS image, seed image called, will add some parts and registration endpoints. This is the way how the image is then calling back to my Rancher server and create for me an installation ISO or a raw image, which I can use in virtual machines or send over to my hardware vendor, say, hey, please pre-install this image already on my host. Then I'm powering on my host system. Here, everything already is in place, and it will, using the registration endpoint, to call back to my Rancher server. And here it's just getting this in an inventory. The inventory can be added or mapped with a label, and based on the labels, the Rancher system agent will start installing, configuring the Kubernetes part on this. So this is more or less, at this point, the normal way how Rancher would start and bring up a Kubernetes cluster. So an update works quite similar to the copy one, just that we do not need to add an additional node. So here we have a new image. Oops. What's this? I have stopped my presentation, I believe. Here we are back. I use my finger, this is easier. So we have a new image. We deploy on the same server, just on a different partition. So we do an A/B deployment. We drain the node so that all the active containers are going away. We reboot. Now we are rebooting in the new image. And if this has finished, the node is coming back, and we go on to the next one. This is completely integrated in Rancher. Yeah? So you have now one console to manage your containers and also your host OS. I need to speed up a little bit. How are we controlling from Kubernetes these host operations? And this is the same for patching and for using this in Ansible. For this, we have the system update controller. Also, an extension to Kubernetes. We extend this to CRDs with the controller and the plan. And the plan is just, as it says, a plan what's to be done on the node. You can combine this with different filters so that it's aware of on which node should be executed what. Small example here from to how to do this for an Ubuntu system. So we have a secret. In the side of the secret, we define on the one hand more or less a small script. So this is executed on the node. We can have some parameters, like here we define the versions of curl or OpenSSL, which should be implemented. And then we have this resource like a plan. And here we say node selector. So if the operator exists on the node, please execute. And please use this secret. This maps to the secret. And at the end, we have here to say, please start this image. Run inside of the change root of the host. So we are jumping into the file system of my host OS. And we execute the upgrade script, which is defined in this site. In this way, we can do everything what's needed inside of a node, completely under control of Kubernetes in a fast way. And we are executing this. Yeah? Again, we need to define where are these updates coming from. And here we can again ask our good old friends from the traditional operating system, please give us the same repositories as you are doing this for your applications. Yeah? And these are, at the end, the tasks of the normal system management. So the automation, software installation, patch installation, config management, which could be for sure done with the traditional ops, but with the system object controller, we can just use the repositories and have under control this by Kubernetes. Okay. In the description of this talk was also mentioned Edge. And everything what I told until now is fine for traditional data center, also in the Edge area. But Edge is also a little bit different. And here some of the challenges what we see. On the one hand, if we are looking at the network, if I have an edge deployment in a shopping mall, a shopping system, I can't trust the network between myself and the data center. I'm using public networks with VPN or whatnot. This might be available, maybe not. If some construction work is done besides this could be a problem. Bandwidth could be a problem. Same on the operation side. It's not a fine and great defined data center. Yeah, maybe this is just a rack or just a running box under a table somewhere. So you have to think about how to bootstrap this. How can I remote management? I hardware limitations on this side. And also the life cycle could be different, because just running to the system, replace it, is much more difficult than in my traditional data center. And I'm talking about completely different scales. So if I have hundreds or small number of thousands servers in my data center, on the edge side, we are talking about 10,000 servers. How to manage this. And Kubernetes is doing this quite well. Last point is the access, so security is also completely different. And for this, we need a completely different approach of operating system. And I will just touch this on a quick way. So it should be small, so that bring up and deployment is fast and easy. It should be transactional, because then we have a read-only part. Read-only means nobody can change something. Small and read-only makes it secure, because the attack surface is going down. I would like to have a long life cycle, so I can have this installed and running for 5 years. And I need a central management. Example for this, SUSE Linux Micro. Or Micro OS, this is the one which is based on OpenSUSE, something like Talos, CoreOS, or Flatcar. So existing. For sure, and this is the small advertising part which I need to do in such a session. So here, advertising for SLE Micro. It has a minimal footprint. We have the immutable file system. A little bit special, and this is if you are talking about edge locations, and why are you doing edge? Because of low bandwidth. Maybe you need a lot of CPU power there, GPUs. We are talking maybe about telco use cases. So there you need something like real-time kernel, DPTK, fast timing performance. So to have this high precision time code for it, for example, this is completely supported. And we have also included in health check, because it's immutable. So every change would mean you will reboot. In this reboot, we check the health of your services. If it's not running well, we are always be able to roll back. Okay, this is really fast because I need to jump up. Last part is security, and this is already mentioned here just as a summary. Be aware of your supply chain, especially if we are talking about edge. This is another entry point to your systems. You need to be aware of where is my software coming from, and how do I make sure that what's getting in, and this is nevertheless if it's your own build chain or the build chain of your provider, how do you make sure that what's getting in really is what getting out, and nobody is able to put any suspicious code inside of it. So, summary. My most important part is don't forget the OS. Not only because I'm working for SUSE and we love our operating system, but I believe it's really important. Even if we hope that the dependency on this is not so much important anymore, but it's important to have a secure, compliant operating system as a solid base for your application. And this means also for your host OS, but also for your container images. I explained 2 times images patching. What is the best? I don't know. It depends on what is your use case, what do you have already, how you adapt, but be aware of there are both options. And inside of the Kubernetes cluster, have a look at this system update controller. It can help a lot to automate these updates. And here I would be on my end to say thank you, and I'm open for questions.
It has been exactly 30 minutes. That's impressively perfectly in time. And we do have questions for you, which we will see in a few seconds, but I will read them also out for you. So if the Elemental ISO is based on SLE Micro, do you need to buy an SLES license to use it?
Yes, because otherwise I don't know how to feed my children. Yeah, just joking. So for SLE Micro, there is also the Micro OS, which you can use. For an enterprise usage, we always recommend use the supported OS, and then you need a subscription. But to just try it, start with Micro OS, and it's completely free.
Thank you. So what is the difference between Elemental and bootc?
I can't answer this in just one sentence. Please come back to our booth and we discuss this.
Okay, thank you. How do you manage the KP or Rancher management cluster?
So the Rancher cluster is a dedicated cluster, yeah, at least this is the chicken and egg problem. You have to manage this on your own. Yeah, but it's just one application. It's one Helm chart at the end, which you manage, and one cluster.
Thank you. How does it compare to Ansible/AWX Tower?
You would be fine to know what do you mean. To which should it be compared?
So then this is maybe also a question for the 10 minutes break, right?
Yeah.
Or for coming to your booth too. I mean, that's
right.
Could be an option too. Okay, awesome. Then let's go for the next one. How is KPI related to BIOS or various firmware updates?
So this is a feature of MetalCube. So MetalCube is able to do firmware upgrades via the Redfish API, depending on which hardware you are using. So Redfish is an industrial standard, and as an industrial standard, every vendor has his own interpretation of it. So it may work or may work not.
And the last one, is Elemental also available to use for free in Rancher Community Edition?
Think about my children. Sorry, my children. Yeah, think about it. Yes, I believe at this point, yes, we are starting with the Prime version to reduce a little bit the availability of these extensions, but Elemental itself is available and can be used.
Wonderful. Now I have the notification question archived. Okay. Does Harvester implement this image lifecycle, and how do we customize the Harvester OS for specific hardware requirements, e.g. like disabling auto-NAC?
So Harvester is based on Elemental, but this Elemental is completely under our control. So you can't customize the Elemental itself. Harvester has some hooks where you can adapt and change it. Best way is if you have any need to do changes, please ask us that we change the Elemental or the Harvester OS for you. So open a support request. Again, here, think about my children. We need a subscription. And then you can open support request and we can adapt this to make it better working with the hardware requirements.
Thore, thank you so much. So the persons who asked these questions, meet Thore later. For the rest of you, please again clap your hands together for Thore. Thore, thank you so much for your talk.
Okay, thank you.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.